Hi everyone, this is Danielle going over the CMYK, RGB, color modes, and more. So starting out, we'll go with the RGB, which is the red, green, and blue. It's an additive color model used for our screens, and I actually looked more into depth of like how it works with the pixels and even subpixels. They use subpixels of lights that are, the red, green, and blue, and they form a pixel, which therefore gets put together with other pixels to form what we see on our monitors and our televisions and on our phones. It's anything and everything digital. And their numeral range goes from 0 to 255. So that's 256 variants in each of these three colors, which gives you over 16 million different combinations for colors just on our screens. As compared to CMYK, which is used for printing and is a subtractive model. Now, the CMYK, as you know, is the cyan, magenta, yellow, and key, or black. They used key so they wouldn't actually have another B in this one, so it wouldn't be confused with the blue, which is the B in the RGB. Unlike RGB, though, the numeral values are actually percentages that goes from 0 to 100%. And so it's not like the RGB that has the set value. So what I found is why they always say that you have issues converting RGB to CMYK is because of these ranges, this numeral range. So for CMYK, for printing, you have 4 times 100 a numeral range for your printing color model, as compared to your RGB, which is actually 3 times 256, which is a considerably higher number. So I found that actually very interesting to find out just why, you have those problems converting. Now, the Pantone matching system I found out was developed by a gentleman named Lawrence Herbert for the Pantone company. So this is a standardized color matching system. A lot of people use this, so I won't say everybody, across different industries and manufacturers to ensure the use of the same color. So, you would have these values set in this guide, and I could go to one print shop and get something done, and then I could take it to a different one, and it's going to be the exact same color. There's not going to be any differences in the values. This is used in not just in printing, it's used in fashion and graphic design and so many other things. So, and it's really cool, really fascinating to learn about and look into it. So, spot color is in offset printing specifically. A spot color is the color that's generated going over with a single run, which means it's not going to be colors stacked. It's the purest color put down in offset printing. While on the other hand, you have process color, which is the color that is made of printing a series of dots and different colors together to get a desired the desired color. Now, color gamut is the range of technically is the range of colors that we can see visibly see with the human eye. That is the overarching definition. But you get various different gamuts as you go into your RGB when you use your computer screens or your monitors. And even more so, it's even more limited when you use printing. You can kind of see over on the right just to get an idea. And I mean, I didn't realize that these gamuts get so specific. So you have your RGB, your CMYK, you have just the plain visual one that we see. And you have the sRGB, you have the Adobe RGB, which are two different ones that are used for your computer monitors and your phones to help set the colors. The more popular is the sRGB due to the fact that the technology is still trying to catch up with just how advanced the Adobe one is. But you also have the DCI-P3, which is used in your filming, your movies. You also have like the NTSC, which is television. And then you have even more that are used outside of the United States. But I just thought these were really cool, and it was really interesting and fascinating to learn about. I love color, so getting more of an in-depth idea on how it works and how it changes from media to media. It was a lot of fun. But I hope you have a good one, and you'll have a wonderful afternoon.
Who are you talking to?